Hello everyone, welcome to today's class. Hope you all are doing good, staying healthy and safe. Today we're going to be discussing routing and switching essentials from the course, chapter number 2, static routing. If you all can hear me well, if everything is fine, you can let me know by writing a comment, possibly. Let me have that screen open also, so I will be able to notice if you are responding, if you are writing any comments. I'm going to keep it here. Okay, concurrent viewers 4. Okay, I will have that. Okay, so let's get started on chapter number 2, static routing. 2.1.1. Okay, as we know, what is routing? Routing, we know that it's the finding out the best path when sending a packet to a remote network. So a router does that job. When a packet comes to a router has to route that package to its destination or towards its destination. It may send to that package directly to that network, or if that network is far away from this router is going to send this package to the next hop router, and the next hop router takes it to its next hop, and so on, and it keeps going. That is routing. We know that. How does the router know the best path? Because there is a routing table in the router. How is the routing table created? Who makes the routing table? How does the router make up that routing table? That's what we are discussing today. There are two ways that a router learns about route and makes entries in its routing table. One of the ways is manual, as you see in the chapter. I am on the slide number 2.1.1.1. There are two ways that a router learns its routing table or creates its routing table. One way is to do it manually, one is to do it dynamically. Manually means router, you being the network administrator, you can write down an entry, a line on the routing table. So the router is going to know that you have written that. The router is going to mark that line with an S in the very beginning of the line. That means it's static, it's manually written, and it is going to have an administrative distance of 1, meaning it's a very preferable, strong route, very reliable, because a human has written it. Then router is going to have some other entries in the routing table that will start with C, meaning connected. That will be a directly connected network. Okay. Uriel says, we can hear you just fine. Wonderful. So that makes me more get started. Okay. So that's manual. Okay. So if you see in the routing table a line that begins with C, that means it's a connected route. Meaning, for example, if you look at this picture on my screen right now, R1 learns about several routes. Okay, let's see. Make it bigger. Okay. Here, this R1 router has two routes, 192.168.10.0/24, that network, connected to gigabit 00, that interface. That is directly connected. So this network 192.168.10.0/24, we know that this network can have 254 nodes or hosts addresses. Dot 1 to dot 254. So dot 1 is assigned to the router. Router has this gigabit 00 interface where this network is connected. Then this router also is connecting another network, that is this. If you see, look at my mouse's pointers movement, 192.168.11.0 also /24, that network can also have 254 hosts, dot 1 to dot 254. So dot 1 is assigned to this interface of the router. That is called gigabit 01. So this router has two separate networks connected to its two separate interfaces. Okay, so automatically this router is going to enter these networks into its routing table with a C, meaning they are directly connected. Router knows 100% sure that they are directly connected to it. Now, as opposed to, if you look at my mouse here, 10110, this network right here is not connected to R1. It is far away with an WAN connection, wide area network connection. So R1 would not know about these remote networks. Other than the two ways, then this will know. One, I can go into the R1 and manually write down that, hey, there is a network 10.1.1.0 with a subnet mask 255.255.255.0. That network is, for that network, your exit interface is serial 000. If you have to go to that network, go out through serial interface serial 000, or look for the next hop router, which is R2. R2's address here is 209.165.200.224. Well, 224 is the R1, so 226. 224 is the network, sorry. 225 is the R1, 226 is the R2. So next hop address will be in this case 209.165.200.226. So this router is going to be looking for that address, which is the R2. So for this remote network, R1 is going to send data to R2 or this address. Okay. So R1 can learn this route. As I said, I can manually go and write it down with an IP route command, or R1 and R2 can talk to each other via protocols. Excuse me. Via protocols such as EIGRP, such as OSPF, RIP, those kind of protocols. With routing protocols, routers will talk to each other, share information with each other, and dynamically write or automatically write that down in the routing table. That's called dynamic. Okay. So going back to there, that's why two ways to learn about a route: manually or dynamically. Hope that makes it clear. Okay. And next slide. Why use static routing? Now there would be a question. Okay. Why would I, being a network administrator, just manually go and write down the routing table entries? There are lots of advantages. Okay, there are lots of advantages and lots of disadvantages also. Okay, dynamic versus static routing. Again, make it very clear. Static means when you are manually writing down the routing table entries. That is static route. That is an example of a static route. Dynamic means when routers are talking to each other via routing protocols, and they are creating new routes and making those entries in the routing table. That's dynamic. Now, look at this. Configuration complexity. For dynamic route, generally independent of the network size. So no matter how complex your network is, say you have hundreds of routers, you have a huge network, just think how difficult will it be for you to keep on writing static routes. That will be very difficult. As opposed to you only have one router, you only have a couple of networks connected to that router. It's very easy to write static route from this router to your ISP's routers. You know that from your networks, if the data any packet has to go out to the outside world, you're going to only go through that ISP's network. Only one router you have to connect to. Then it's easier to write down a static route. So static route, the complexity will increase as the network size increases. But with dynamic routing, no problem. Routers can talk to each other and find out the routes, no matter how big or how complex the network is. There is an advantage here for dynamic routing. Topology changes. Automatically adapts to topology change. Well, if you are using dynamic routing, then anything changes, any router is removed, IP address changes, some routes become blocked, whatever happens, routers are going to talk to each other and update that automatically. And if you are using static routing, then the administrator has to go and change that route manually, write it down. So that's the disadvantage of static routing there as well. Scaling. Dynamic route is suitable for simple and complex topologies. Dynamic route is good for any topologies, okay, scaling wise, meaning if you want to make it big, all of a sudden add more routers, change the topology, make changes to your network, as I said. So dynamic routing is going to adapt to it by itself, okay? And static routing is suitable for simple topologies. As long as your network is simple, routes are not changing, these are all known routes, okay? Those you can write down manually, statically. Security. Now, dynamic routing is less secure. Static routing is more secure. Dynamic routing, in dynamic routing, since routers are talking to each other a lot and learning the routes by themselves, a hacker can go make some changes, send some signals, pretending to be a router, and sharing that information with your router, and using the RIP protocol, OSPF protocol, whatever protocol that may be using, and give you wrong information to your router, and your router is going to start, building the routing table, making changes to the routing table with the wrong information. It is less secure. Static routing, since you are manually writing down the static entries, so it is more secure. Okay. Now, resource usage. Dynamic routing has a disadvantage because it has to talk to all other routers and always share information to update the routing table. It will use more CPU, more memory, more bandwidth, and static route is not doing that. So there's no question of extra CPU, memory, or bandwidth use. Predictability. Route depends on the current topology. And so depending on what has happened recently to the network, how the network has changed, it depends on the current topology. Dynamic route is continuously changing. So you do not know right now this data is going to take which route. You have to look it up in the routing table. On the static route, since you wrote down, the route is going to be always same. Your computer is sending, your router is sending from this network to a destination network, always through the same path, because you wrote that down. This is statically written. Okay. Okay. Now let's move on. When to use static routing? Then you may say that, okay, how do I decide? Do I use static routing? Do I use dynamic routing? There are some scenarios where static routing becomes more useful. Here is a picture. Here is a scenario. This is called a stub network. Okay. A stub network is where your topology is very simple. To reach this particular network, 172.16.3.0, that particular network, no matter who from where in the world wants to send data to this particular network, it has to go through this R1. There is no other path in the world. So the data has to eventually come to R1 in order to go into this particular network. Okay, so this particular network is taken care of by only one router, that is called a stub router. In this simple scenario, a static routing is more useful, having the less overhead of the CPU and memory and processor and all of those things, bandwidth. You don't need to use that. Just write one line of static route. And think of this network, this stub network, for computers that are in this network. For them to go out, R1 has to send the data to the ISP's router here. So this router R1 is connected to R2. R2 is the only way to go into the outside world. Therefore, in this scenario, a static routing would be good. R1 knows that all the packages other than this network, other than this internal network, for all other destinations, I have to send the package to R2. That's it. So in this kind of simple scenario, for a stub network, okay, always remember, stub network is a network that is handled by one router and has only one way to get out. That's called a stub network. So static routing is good in this. Now let's do this little activity in here. Activity: identify the advantages and disadvantages of static routing. Okay, fine. I will have to go back to make it small, otherwise it becomes too big. Configuration complexity increases with network size. So a static route we're talking about here. Okay, static route, as the complexity increases, your network becomes more larger, more complex. It's difficult to maintain static routing. You have to keep on going and changing it. That's a disadvantage. How about this? With the static routing, no extra resources are needed. Well, that's an advantage. Your router is going to run more smooth. It will not be overwhelmed. That's an advantage. Topology changes will affect configuration. Number three, since topology changes will affect configuration. Well, that's a disadvantage. The network topology changes and your route is not being changing because you have to go manually change it. Route path to destination is always the same. That's an advantage. Routing tables are small and maintenance is minimal. That's an advantage too. No automatic updates will be made in the routing table if topology changes. That's a disadvantage. So let's check that. Yes, we did good. So there are advantages, there are disadvantages of using a static routing. Okay. Next, static routing applications. Okay, to use static routes to connect to a specific network. Sometimes you have a specific network that that's a known network. You know that network is located with this other. I see. I did not turn on this microphone today, and I do not know whether you're going to be hearing now or not. If there is any disruption to the voice, let me know. If there is a disruption to, to my audio, so I realized that what I was using was the audio from my camera itself, and I have forgotten to use my microphone. So earlier, Uriel said that you were hearing just fine. At this time that I have this microphone on, I don't know whether it's automatically going to switch to it or there will be a disruption. So let me know if there is a disruption in the audio, okay? Or if you're hearing it very well, still let me know that, please. Thank you. Okay, so when do I use the static route? Connecting to a specific network, a known network, fine. If I know the route, I can write it down. Number two, connect to a stub router. Yeah, a stub router is a router that has a network or two connected to it, and it has only one way to get out to another router. That's a very simple network. It's called a stub network, stub router. Then summarize routing table entries. Sometimes very similar networks like 172.16.1.0, .2.0, .3.0, very similar network, and the last digit may be different. All of those networks can be summarized by one entry. We'll discuss that in the coming slides somewhere. You use a static route to make a summary route. Okay. Okay. And then somebody said, and Teresa said the sound is good. Okay, wonderful, great to hear. Okay, and then also create a backup route. Sometimes what you do, you have already one route that your router knows. Take that route to a destination network. Fine, everything's working fine. You know the route. Then you thought that, hey, sometimes that other router, if it goes down, this particular route will not work anymore. Let me create a backup route. I'm going to have another path via another router. That's going to be my backup route. But on that backup route, I don't prefer that my router uses that backup route. That's maybe a slower connection, but I still want to keep it as a backup. So you write down another route as a backup route an additional path, but which is not preferable. So you put a higher administrative distance. We will learn how to do that. When you add a line in the routing table, you add a little number. That's called administrative distance at the end of the route. That will tell you that, or in the middle of the line, that will tell you that this route has a higher administrative distance. Don't use this route unless this preferable route fails. Okay, and that's called a floating static route. A backup route is also called a floating. So let's see an example. Standard static route. I'm in the next slide. This is the simplest one. Look at this scenario here. Here is a stub network 172.16.3.0. We know that network is connected to R1. Fine. So in the R2, in this router, in its routing table, it does not have that information. Which information? The network that is connected to R1, that network information. So you can actually go into the R1, R2, manually write down that, hey, this network, destination network 172.16.3.0, for that network, you got to go out via S000, this serial interface, or you can write down this R1, its IP address. Okay, so that's the next hop. So R2 will know in order to go to 172.16.3.0, in order to go to that network, R2 has to send data to the R1. You can write a static entry. Okay, we'll learn how to do that. We use IP route command. That's coming. Okay, next, a default static route. Look at this scenario here. Look at R1. R1 has one or more or many networks here. An example is this one. Fine, same example. But if a PC1 from this network wants to go out to the internet, then R1 has to send that packet to R2. That's the only way to get out. That will be a default route, meaning anywhere else in the world, any network, any other unknown network, no matter what network that may be, all the networks in the world, if PC1 has to access all the networks in the world, any network in the world, then it sends a request to R1, and R1 says, I know what to do. I have a default route. The default route is this. That's R2 is my next hop default router. Okay, so that's called a default route. And how do we write? We write this way: 0000. That's the IP address. That's the network address. 0000 with a zero mask, meaning all network, every network in the world. For that, R1 has to send all the packets to the R2. There's no other path. That's called a default static route. Default route does not have to be always static. You can manually write down. Now we are discussing static routing. Okay, so we will learn maybe in some slides later how to write that command. Okay, we write that command by using the command IP route and then 0000/0. You will learn that in the coming slides. Okay, next, summary static route. There is another kind of static route that you write down statically. Here is an example. Look at this situation. This router right here on my left, this with the serial interface, this router has so many other networks: 172.20.0.0, 22.0.0, here is 21.0.0, 23.0.0. All these networks, they all have to go through this router right here. If you look at, they didn't write a name to it, but this particular router here, if you see my mouse. Now, R1 says that, okay, I learned about this. There are 4 networks, 1, 2, 3, 4. These 4 networks, if I want to go to any one of those 4, I have to go through to my left to this router. So what are the networks? Again, it's written in here: 172.20.0.0, 21.0.0, 22.0.0, 23.0.0. All those can be summarized by 20.0.0/14 instead of /16, because all of them just a little bit different here, 23, 21, 22, like that, a little bit different. Only 2 digits in binary becomes different. Other than that, all are the same. 172, that part is same. 20, 21, 22, they're very close. In the last 2 digits in the binary, they're going to be different. That's why instead of 16 mask right here, if you do 14 mask, then all of them match actually. Up to 14 digits, up to 14 bits, all these addresses match up with each other. They're a little bit different on the 15th and 16th bit, like if you convert this into binary. So that's why these do /14, meaning up to 14 bits, they all are the same. These all 4 networks can be summarized to this network, 172.20.0.0 with a 14-bit mask. That's called a summary static route. Instead of writing all 4 lines like that, you can write just one line like that. Okay. Next, a floating static route. Here is an example. Here is a company is going to the headquarters per se, this HQ. This router with this purple color path is going to the headquarters, and it is their preferred route. So you write a static entry that in order to go to the headquarters, this network 172.16.0.1.0 with 30-bit mask, serial 001 right here has .2. On my right, serial 000 has .1. This belongs to a network right here, with WAN, wide area network, but they belong to the same subnet. That is our preferred path to go to this router. But in case this connection goes down, you have another option. You can go in this down with the gray, with this dark gray, through this path to the same place. So what you're going to do, this second path, the bottom path, this path is going to be not your preferable path, but as a backup route in case the top connection, the purple connection, goes down. So you can create a manual entry for this path, for this route, and put an administrative distance of higher than whatever this top routing is saying. If you, for example, if you write this purple route as IP route, then this network, whatever the network you are going, that network, then the subnet mask, and then your exit interface, it's going to have administrative distance of 1 because it is static route, because it is a manually written route, static route, always have administrative distance of 1. Then you write down another path manually, again this path, and this path you put an administrative distance, say 10 or 5 or something. So router is going to always look for this route, purple route. Will never take this gray route unless the purple route is not available, has gone down. Okay, that's why you keep a backup route. It is also called a floating route with a higher administrative distance. Okay, let's see, look at this activity. Okay, now activity, identify the type of static route. Okay, standard route or default route or floating route. Well, we need to know then what they are. Let's read one by one. Backs up a route already discovered by a dynamic routing protocol. What would be a backup route called? What is a backup route called? It's a floating route. Okay, so say EIGRP protocol, RIP protocol, OSPF protocol, those protocols already found out a route, and you wrote down for the same destination an additional route with a higher administrative distance. That will be called a floating route. Okay. matches all packets that sends them to a specific default gateway. Okay, so all the packets that sends them to a specific default gateway, that's a default route. Useful when connecting to a stub network, that will be a standard route, very simple one. Okay, stub network is a very simple network, very easy. So that one will be a standard static route. These are all we're talking about, static routes. Okay, configured with a higher administrative distance than the original dynamic routing protocol. What do you, when do you use a higher administrative distance? Meaning it's a backup route. It's not a preferable one, but as a backup one. That will be a floating route. Commonly used to with edge routers to connect to the ISP network. So if you are a very simple network, you are connected to your ISP. So for all the outside world, you will be throwing all the packets to whom? To that ISP's router. That will be a default route. Okay. So let's check. Okay, we're good. So just remember, a default route takes all the packets to a default gateway. Okay, to a next router, like your ISP's router. The same thing as the last option right here. A floating route, again, is a backup route that has a higher administrative distance. It is an additional route. That's called a backup route, okay? I'm repeating the same thing. Make sure that you got it. Okay, next. Okay, now we are learning how to write a static command, how to write an entry in the routing table, how to write a static entry, static route. Okay, here is the command, IP route. So basically, here is the command. You're in the router, you're in the global config mode. You type up IP route, then you put network address, subnet mask. Okay, so the network, the destination network that you have, and its subnet mask. You know that a subnet has either 24-bit or whatever mask. So you're going to be writing that down in here. And then what is this IP address? IP address is your next hop router's IP address. It's not your IP address. So that means in order to go to this network with this subnet mask, you send the data to this network, that IP address, or your exit interface, or you say, well, get out, this packet should get out through my serial interface or gigabit 00 interface. That's the exit interface. Which interface do I go out to find that destination network? You write that down. Okay. Okay. So next. Okay. Next hop option. So let's look at a scenario in here. Okay. R1. R1 has one network, 172.16.30, that is connected to itself. This one, R1 is going to learn automatically. Just as soon as you configure this interface, R1 will know which network it belongs to. That's easy. How about this one network right here? This, if you see my mouse, this network right here. This network is between this R1 and R2. That network is this 172.16.2.0. This network also, R1 is going to learn by itself automatically, because as soon as you configure this serial 00 interface, it will know which network it belongs. So these two networks right here, 2.0 and 3.0, these two networks R1 automatically knows. Now let's talk about another network right here, 172.16.1.0. For that network, R1 does not know. So you have to actually write an entry in the routing table stating that in order to go 172.16.1.0 to that network, R1 has to send the data to R2, this dot to that right here, this dot to that interface. Maybe I can make it bigger. So R2's serial 000, this interface, its IP address is this 172.16.2.2. Dot 0 is the network, but dot 2.2 would be this address right here. That's his next hop address. Or in the R1, I can write to go to this network, send the data out via S000 interface, either via exit interface or the next hop router's address. Okay. Here I am doing a show command. Here I'm not writing a route. I'm just looking at my routing table. So I typed show IP route, and then this pipe and begin gateway, meaning the line in the routing table that has the word gateway, just begin there. So the router has some more lines in the routing table. It's not showing those. The word gateway starts from there. So that's one of the ways to shorten the output in your command. Okay, basically he's doing show IP route, that command, but he used a filter to make it the output specific to where the word gateway from that point onwards. Fine. Look at the second picture. Okay, um, these are C and L, by the way. C means directly connected networks. Right here, 172.16.1.0, that is directly connected to the gigabit 00 interface. Okay, and okay, then L. L is the directly connected gigabit 00. You may say, hey, why is C and L? I did explain in the last class. I'm going to explain again. C, look at this very carefully. C is talking about a network 1.0. That is a network address. That is not a single IP address with 24-bit mask. So that is connected to gigabit 00. So my router knows that this whole network 172.16.1.0 with 24-bit mask, this entire network is connected to this gigabit 00 interface. Then it says L with the same, almost the same, but this is 1.1. That is the actual IP address of my gigabit 00 interface. That is not a network address, it's an IP address. So that's just two lines always. This is actually my own IP address of the interface, and this is a network that is connected to me. Okay, that's how C and L. Number 3. Okay, again using the show command, include C. That means the line that begins with C, those are the ones I'm looking at. So two separate networks showed up. They are connected to, one is connected to serial interface, serial 001, one is gigabit 00. Okay, just showing you the show commands. Ping, no biggie, ping, no biggie. Okay. Now, but it's important thing it's telling you here the 3 following types of route types. One is the next hop route. This is important for you to understand. Actually, I should take a moment to tell you this. When you add a route, when you write a routing entry in the routing table, you can use only the next hop IP address, next hop router's IP address. You did not specify which interface to go out through, like serial interface or gigabit. You didn't say that. You only write down the next hop's IP address. That's called next hop route. Directly connected static route, that one only will have, there is no next hop to it because that network is directly connected to you. So you're going to be only using the the exit interface. And fully specified route, number 3, that one, the fully specified route, that one, you're going to have both next hop and IP address, the next hop IP address and the exit interface both specified. And we're going to demonstrate, we're going to show you that in the next screens, probably somewhere. Okay, configure a next hop static route. Okay, here, how do you configure it? Again, you're in the global config mode. You click on IP route, then you type up the destination network, you type up the subnet mask, and then an IP address. What is this IP address about? That is your next hop router's IP address. That means you're telling your router that, hey, to go to this destination network 172.16.1.0, to go to that network with this subnet mask, try to send data to this router 172.16.2.2, just right here. Look at that. 172.16.1.0. This network is not directly connected to R1. So you're writing in the R1 that, hey, to go to this network 1.0, that network, go to this router R2. Now what is its IP address? Its IP address is 172.16.2.2, not 0. See the dot 2 right here? So that's the IP address. So that's what you're writing right here. So 172.16.1.0, to go to that network with this subnet mask, go to the next hop router, that is 172.16.2.2. That's how you write a next hop route. Okay, you did not say get out through S00 interface. You did not specify exit interface. You only specified next hop router's IP address. This is one way, one of the ways to write a static route. Okay. Okay. I'm not going to go the same thing. I'm not going to go over. You can practice it by yourself, typing those commands. If you didn't know how to do it, just click on show me, and it's going to tell you exactly how to write. So it's no worries. You can write down those. Okay. Next screen. Okay. Now configure a directly connected static route. In this case, you can write down a static route, but that destination network is directly connected to R1. For an example, IP route 172.16.1.0. Okay, this 172.16.1.0, and that is, you have to get out is serial 000. See, serial 0. Now you are specifying. Now you are specifying a serial exit interface instead of writing down the IP address of R2. Now you are specifying that, hey, go out through this interface. You're going to automatically reach to R2 and go to that network. Okay, so that's what it's telling you. And it's show IP route, show commands, and your practice here that you can do yourself. Okay, so static route we're doing. Okay, now next, this time I'm going to specify a exit interface which is gigabit 01, also the IP address of the next hop router. I can do that. I can write both. Here's what I did. Again, I use the command IP route, then the destination network, the subnet mask. You understood that, the same thing. But now I'm saying go out. To go to that network, you have to go out via gigabit 01. And I'm also saying that my next hop router's address is 172.16.1.1. Sorry, 16.2.2, right here. Once this interface right here, that is 172.16.2.2. So I'm specifying the next hop IP address. I'm also specifying that go out via gigabit 01, the exit interface. So I'm specifying both. That is called fully specified static route. Okay. So static route could have been, I could have done, again, I'm repeating now, summarizing. On this line, I could have written just the exit interface. That would be okay. I could have done just the next hop IP. That would be also okay. Or I could specify both of them, exit interface and the next hop IP address. When I specify both, that is called a fully specified static route. That works. If I did just the exit interface, okay, that would also work. If I did just the next hop IP address, it would also work. But what happens when I specify just the next hop IP address? I do not say which interface to go out. That kind of route is called the recursive route. I don't know why we didn't discuss that. Maybe in somewhere it did. We didn't see it, but I'm going to discuss that anyway. When you specify just the next hop IP address, you did not specify the exit interface, that route would be called a recursive route, because router still does not know. You put in next hop IP address, Router does not know which interface it has to go out through, which interface you have to go out to in order to go to that next hop router. So it's going to look that up again. That's why it's called a recursive route. Okay. So eventually it has to know which interface to get out via. So look at it here. This is a static route that is fully qualified. This is right here. This one is IP route, that the destination network, subnet mask, and this one is just saying which interface to go out. Okay. Next, verify a static route. And anything that in Cisco router or switch, Cisco equipment we do verify, we use this show command. Show IP route, that is the command to display your routing table. If you type show IP route static, show IP route static, only the static lines that you wrote down manually starts with an S, only those will show up. If you type show IP route and a specific network, only that line of the routing table is going to show up. The lines that have that network's reference. Okay. Here is an example. Here are some examples, I guess. Show IP route static. So only static routes are going to show. Then you added a little more qualifier, more filter to it. Begin gateway. So begin the showing where the word gateway appears. So right here, gateway of last resort is not set. All these three entries that's showing S, 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 all are static because you typed show IP route static. Only static routes are being shown in here. Okay, these are the ones the administrator manually wrote down. Okay, and let me tell you a little bit more on that. Look at the first line with S. 172.16.1.0, 10. What does that mean? Well, this 1 means its administrative distance is 1. It's a static route. And 0, this metric, didn't put any number on it. That's okay. Okay. The first number here is the administrative distance. So all three routes, they have administrative distance of 1 because that's the default administrative distance when you manually write down a route, static route. Static routes by default would always have administrative distance of 1, meaning it's very highly reliable. Okay, because a human wrote it. Okay. Okay, now, and it's more various show commands. So see show IP route with this network, just show commands and show commands. That's okay. You can use the show commands. It's no big deal. Next, default static route. So this is something we need to learn. How do you write a default route? Again, what is a default route? A default route means any network that is not specifically written as a specific network. That means all network in the world that are not found specific reference in your routing table. For those networks, for those destinations, my router has to send the packet to the next hop default router, my default router. Okay. So how do I write that line? Here is how I write. IP route 0000, meaning all network. 0000 mask, meaning, so when I have 0000 the destination network address, 0000 mask, that qualifies all network, every single network in the world. For all those networks, you're going to send the data to this IP address of the next hop router, or I can say go out via this exit interface, which could be serial 00 or whatever the interface is. Okay, simple. That's simple line that I have to write. IP route. Now you may say that, okay, I have a question now. If I write this line, I would have this line written. I would also have some more lines written in my routing table also. They will have some specific reference to other networks as well. So since this particular line with the default route, all network qualifies in here. So which one my router is going to choose? Always remember, router is going to choose the most specific match. The most specific match. This default route is going to be used only when no other line matches, more specific line matches that network. Only then you're going to send that to the default network, default router. Oh, okay. So if a destination network matches another line that is more specifically written for it, the router is going to use that line, that route for that destination, not the default one. Default is the last one. That's why the default route is also called gateway of last resort. Gateway of last resort. Okay. When no other match is found, I'm repeating, when no other match is found in the routing table, that's when this line will be used. Okay. Now next, configure a default static route. Okay, just basically what we have just learned is just asking you to practice, I guess. So okay, next, verify a default static route would be show IP route static. Show command. These things not much to learn here, just to practice. You can do that. And we're going to have labs where we'll be practicing them. Just keep on moving, keep on going. Okay, Ipv6 route command. Now, we already learned how to write a routing entry in the routing table using IP version 4, how to verify using the show commands like show IP route static, show IP route, then a network address, things like that. We have learned all of those. How about IPv6? That's what we're going to discuss. Exactly the same way, same thing. All we have to do, just IPv6 route instead of IP route. Here, how do I write a command to write a static entry into my routing table using v6? Here is my command. Again, before what was the command? IP route. Now I'm going to write IPv6 route. Everything else is same. The network address and the prefix, subnet mask could be the prefix here. IPv6 address of my next hop router, or the exit interface like serial 000. The same format, same everything. All you have to do, whatever you write IP, here you write IPv6. That's all. Okay. So, and of course there'll be some practice, some demonstration, I guess. Yeah. But this one other command that's very important. Okay. IPv6 Unicast routing, that you use right here in the global config mode. IPv6 Unicast routing. This one command you have to use, otherwise IPv6 will not be activated. Your router will not be forwarding, routing IPv6 packets if you did not use this command to begin with. IPv6 unicast routing. Make sure to use this command if you are using IPv6 addressing and routing. Okay. So now IPv6 unicast routing. Okay, they're asking you to practice. I can click on just show me. Yeah, that's how you write this command. Okay. Next hop option. Now I'm going to write a static route command, a static route entry into my routing table with IPv6 with the next hop router's address, IP address. So easy. I'm going to write IPv6 right here. I'm in the screen number 4 right here. Let's blow it. I'm in the screen number 4. It's pinging. Sorry, it's pinging. So they already they are just showing the show command in this case. Okay, they didn't ask you to write it. Just use the show command. Okay, fine. But you will be writing this way: IP route. Okay, just the way you write, same way you're gonna be just using v6. You're gonna say IPv6 route and the destination address and the subnet mask and the next hop IP address. It didn't show you here. I'm sure we're gonna have labs. So next hop static IPv6 route. Here you're gonna be writing down your next hop router's IP address. This one you're going to be writing down just the exit interface. Both would work. If you write just the next hop router's IP address, that should work. If you write just the exit interface, that should also work. And again, the third one is fully specified. You're going to write the next hop IP address and the exit interface both, just like you did in the IPv4. Okay, next. It just, this one shows actually that how to use that command. Okay, good. Look at here, IPv6 route, that's the command. Here's the destination address, 2001 DB8 ACAD 2. Look at this colon colon. It means this is not just a single IP address, it's a network address. Because at the end, all zeros. If you see my mouse, making sure colon colon means all the zeros. That shows an entire network with 64-bit network address. Okay, and then for this destination network, what do? I send the package to this address, 2001 DB8 4.2. That's an IP address. That's the IP address of my next hop router. So in this case, I'm only saying the IP address of my next hop router. And where is my next hop router? Let's take a look at it. Here's my R2. R2 is my next hop address. Now what is its address? Its address is this right here, 2001 DB8 ACAD 4, then colon colon, then colon 2. See right here, dot 2 colon 2 is my IP address. That's my next hop router. So in the router of R1, I'm writing down this line. Okay, and about which network that I need to go. I need to go into this network right here, 2001 DB8 ACAD2. In order to go to that network, my router R1 has to send the data to this next hop router. That's what I'm writing here. The destination network is ACAD colon 2, this one right here. To go to that destination, my router has to send the data to this 4.2, that next hop router. Okay, hope it's very clear now. Okay, next. Configure a directly connected static IPv6 route. Okay, since these two routers are directly connected, it will be easy for me. I don't have to even write down the next hop router's address. Again, this next hop router, its address is colon 2. I don't have to write that. All I have to write, since they are directly connected to me, these two routers are directly connected, so I can say just simply go out via my own interface S000. If it goes out to through my S000, it's going to definitely hit this router. So I don't have to write this IP address. I can only write just go out via S000. That's what I'm doing right here. So let's look at here. I'm writing an entry. This time I'm going to only specify which exit to go out through. So I'm saying IPv6 route, this destination network. Where is that destination network? Right here, all the way here. To go to this destination network, you know that I have to go via R2. But this time, I'm repeating, I'm not writing the IPv6 address of this router. Instead, I'm saying simply go out via my interface of S000. Then you're going to hit this router and you will be able to go to that network. Okay, so that's another way to write your route. Or I could have written both. I can write the exit interface and the next hop IP address, both. Here's number 2. Number 3 is just simply asking to practice. So practice is no worry. Again, for the practice, you just click on show me and it shows you how to do that. Okay. Now configure a fully qualified, that is what I was talking about. Sometimes you want to write exit interface as well as next hop route, its address. Okay, so both of them. So for example, here they have written IPv6 route, go to this destination network via my serial 00 interface and also the next hop's address. Okay, link local address. So an address and the exit interface, both. You can do that. Yeah. That's called fully specified static route. Now we're talking about some show commands. Show IPv6 route, show IPv6 route static, show IPv6 route network, things like that. Okay. This network, you actually don't write the word network, you just write the network's address. Okay. You just write the network's address. But this command you use exactly as is. Show IPv6 route. That's the most basic command to see the IPv6 routing table. Show IPv6 route static. It will show you all the static entries, not the dynamic ones, only the static entries, only the entries that you wrote down manually. Those will be shown. Show IPv6 route and then a network address, a destination network address. So that network on whichever line in the routing table having the reference to that network, those lines will only show up. Okay. And it shows right here, for example, show IPv6 route and then a network address you put. See, this is at the end, just colon 00. This is a network address. Then it shows, yeah, there is a routing entry in the routing table. Yeah, there is a routing table entry that refers to this network. So that is, that is shown in here. Next, a default static IPv6 route. Remember, we just did the default route for IPv4 that was like 0.0.0.0.0 IP network address. Subnet mask was 0.0.0.0. What does that mean? That means all the network will match that. Okay, we already talked about that. Same thing now we're going to do for IPv6. For IPv6, we don't do 0.0. Not that way, a little bit differently right here. For IPv6, we just do colon. That means all zeros. And the subnet mask or the network interface address, network address is, the /0. That means all IPv6 network. So all IPv6 network, for that, just go out via this exit interface right here, whatever I can specify, or next hop router's IP address. That's my default router. That's going to be my gateway of last resort. That is called a default route. Okay, I can do in IPv4, I can same way do IPv6, but we write a little bit differently with colon means all zeros and then /0. That's the difference. Okay. If you want to just compare side by side, if I go to the Microsoft Word per se, and just what is the difference between those two? For IPv4, let's see, I'm gonna write down here a bigger size. Okay, for IPv4 you write this way: 0.0.0.0, and the subnet mask is 0.0.0.0. That's gonna be your default route. Okay, you're gonna be writing in the say config, say R1 per se, or router config. You're in this mode. Okay, and you're going to write down here, it's going to go spill to the next line. Okay, that you're going to write IP route route like this. Okay, and then you're going to be writing down, you go out via what, say serial 0 0 0, go out there. That means that's your default route, meaning any network, for any network that is unknown to me, all the network in the world, I need to go out via this interface. The simple line. Same thing on the IPv6, you're going to be writing this way: Control C, Control V. Just to, I wanted to do side by side comparison. For the IPv6, you write IPv6 route. Okay, and then page layout, maybe I can do orientation. That way you have longer line. Okay, IPv6 route, then you don't write 0000. That's the thing I'm trying to tell you. Instead you write colon /0. That's the two different way to write down. Here, this is what you write in the IPv4 for the default route. Again, it is also called gateway of last resort, meaning any and every single network in the world that I need to send the data to, I can send via this exit interface. Or I can write a next hop address of the next hop router. I can do that also. Or I can do both. Okay. And for the V6, this means all network right here. Anyway, go back to the screen. Okay. Okay. Next. Configure a default static IPv6 route. Okay. It's just asking you to do that. Okay. Verify a default static. How do I verify? Again, show command. Show IPv6 route static command. Not much to learn here. Move on and move on. Packet tracer. Next. Move on and move on. Keep on going. Okay. Floating static route. Now we have talked about a backup route. A backup route is the floating route. Okay. A backup route or a floating route would have, that's an additional route that would have higher administrative distance. Higher administrative distance means less preferable. It is not the preferred path. The lower the administrative distance is, the more reliable the route is, more preferable the route is. Now, just to quickly remind you, recall on that, what is the best, most reliable route? The most reliable route is a route that is directly connected to you, that nobody has to write it down. That is, that network is on you, on your hand, that is connected to your gigabit 00 interface. That network is the most reliable because you know you don't have to go through any other router. That is yours. And that you know that also that entry in the routing table would start with what? A C, meaning connected. We have discussed all of those. I'm just summarizing and repeating for you, making sure. That route is going to have a 0 administrative distance, meaning the most reliable route. How about when you write down that IP route, as I just did in the Microsoft Word right now, this one. Manually, I wrote down a default route. What is its administrative distance? A static route or a manually written route has the administrative distance of 1. Okay. So again, directly connected would be 0. Manually written down static route starts with an S. That's going to have administrative distance of 1. And then other routes learned dynamically via protocol like EIGRP, IGRP, OSPF, ISIS, RIP, they would have higher administrative distance. They are not as preferable, but they are learned by the router by communicating with other routers via these protocols. Just all of them, basically I wanted to memorize this between 90 and 120. That's the ones you need to remember, not any other. IGRP and EIGRP, very easy to find out. EIGRP is the best one in here. Administrative distance of 90, the shortest, the lowest administrative distance. Therefore, this is the most preferable among these routing protocols. EIGRP is enhanced IGRP. So IGRP would have, if its IGRP is 100, of course EIGRP would be better than that, so it's 90. OSPF, open shortest path first, that one is 110. ISIS, that's intermediate, whatever I call it, forgot about that, something network, that's 115. And RIP is routing information protocol. It's this, I think, intermediate system to intermediate system. That one is 115. And RIP, routing information protocol, that's 120. Okay, and this interior gateway routing protocol, IGRP, or enhanced interior gateway routing protocol, they are 190. So just know these things, not too many, just a few. You know, these ones you got to remember and memorize. Okay, and then let's move on. Okay, configure an IP4 v4 floating static route. Now what are we doing? Let's understand again. What exactly are we doing? We are writing a backup route. There is already a route about that. I am writing an additional route with a higher administrative distance. That is called a floating route. Okay, so let's look at it, how to do that. Okay, here I am in the R1, I'm in this router. So I write IP route 0000, meaning all networks go to this next hop router. Okay, makes sense. So that's a static route and that's a default route. That's the gateway of last resort, whatever you want to say it. I wrote a default route. Then I'm writing one more line. Look at the second line. I'm writing that over again. I'm writing then again IP route 0000. Well, two different default gateway routes. Yes, the first one is more preferable. Second one is not, because the second one I wrote this. I mean number 5. That means this is administrative distance. It has a higher administrative distance. So this is going to be a floating route. All the time, the router is going to prefer to use the first route, not the second route. If the first route is broken or not available, in that case, it's going to use the backup route. Okay, so the second line is called either a backup route or we call it a floating route. Okay, same thing. And then they're asking you to practice. Okay, you do the practice at home. Next. Okay, test the IPv4 static floating route. Is showing what they did. They did 2 separate routes they wrote down. Then this one router, this is one path via R2, another path is via R3. So they shut down the R2's interface. Once they did that, so this route will not be valid anymore, then the packet is still going to go through. That's how you test. I'm not going to do the test, but I'm telling you how to test. From R1, I have 2 different paths. I'm repeating. R1, I have 2 different paths. One path to go via R2, another way to go to R3, and then go to the other network, whichever you want to go. Now, in the R2, or even here in this case, they are actually doing it in the R2. Okay, so R2, they are shutting down one interface, so it's not going to go through the other way. Then you see the backup route works because you ping and still data is going through, so you will know that even though I shut down one interface, I can still communicate via other interface. Things like that. That's how you test it. Configure IPv6 floating route. Same thing. It's identical, except that you're going to be using IPv6 and IPv6 address. The second line, again, is given a higher administrative distance. There are 2 routes for the default gateway of last resort, not default gateway. Okay, 2 routes for the gateway of last resort, or default routes we call them. Second default route has higher administrative distance. I hope that after all this repetition you're good. Next. Okay, packet tracer, automatically install host routes. Okay, I will just move on. Okay, configure IPv4 and IPv6 static host routes. Move on there also. Static routes and packet forwarding. Move on there also. Okay, troubleshoot a missing route. You can, by troubleshoot, we already know that we do the ping. Okay, type. So we have done this many times in the class. We know that if there's an exclamation mark, that means a success, and if there's a dot instead, that will be not success. So you are trying to ping. You can also use the command trace route. See the trace route, then you can see that which route or which path you're taking from going from one place to another place. From the PC1, if you're going to another network, which route you're taking. Okay, so if there are multiple routes, you can see trace route commands will reveal that to you. Okay, show IP route. In this one, you are displaying routing table, and you want to begin on the line that has the word gateway in it. Okay, so this is all show command, simple things that are letting you show IP interface brief. We have used that command many times, tons of times in the CCNA1. Show IP interface brief, that shows all the interfaces and shows their up or down. Show CDP neighbor, that command shows all other Cisco. CDP is again Cisco Discovery Protocol. It shows all the neighboring Cisco devices. So they're just teaching you some show commands for troubleshooting purposes. We will do all of those when we are gonna be doing labs. Okay, so we'll be practicing these commands. No worries, those labs will come in time. So next, solve a connectivity problem. Okay, again we're talking about this. In this situation, for example, they pinged and the ping went dot 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 dot, meaning ping was not successful. Success rate is 0%. So then they have to fix it, they have to do something about it. Okay, these things I would prefer to do, I will do when we have to do the labs. Move on. Activity. Okay, fine. So that concludes our chapter 2, and I hope that everybody understood, everyone enjoyed. Um, let's see. So I hope that I'll be seeing all of you pretty soon, inshallah, in the next time. But tonight I'm not going to come with the lab. What I'm planning to do, I'm planning to do lab tomorrow. Tomorrow, Tuesday. It's not our regular day, but Tuesday. That's not in my mind. I have the plan. I'm going to do the lab Tuesday tomorrow in the evening time. In the evening time, I'm going to go and do a couple of labs. Okay, before Wednesday. Of course, Wednesday I'm going to do again labs. So Wednesday I may do another chapter and labs. So until then, everyone, stay safe, stay healthy, make any kind of comments in there. One more thing I would like to tell you, that is, I also have set up Zoom so that I can actually meet you all. You all have your webcam at home. If you don't have webcam, just use your microphone to talk. If you didn't have the microphone even, you can still type up, but I'm going to have an interactive class. I'm going to have an interactive class this week sometimes. I already have set up the Zoom for you all, and I'm waiting to meet you all online so where we all can talk. You can talk, I can hear, I can talk, you can hear. It's going to be interactive class, okay? I'm looking forward to it, my friends. Sometimes later on this week. I'm going to send you the email for it. So no worries, okay? So everyone, have a great day and enjoy. Let's see how to stop this one. I say end stream. Okay.